Welcome to our lesson on trigonometric ratios, or trig ratios. Today's objective is I can find all the trigonometric ratios, sine, cosine, and tangent when given a right triangle. Okay, so the first thing we have to be able to do is label our sides before we can find any of our trig ratios. You notice down here at the bottom right corner, we have theta. Okay, it's a little circle with a line through it. Theta is a Greek letter that we use to indicate angle, and that is the angle that we will be referring to when we find these trig ratios. So let's start off with labeling our sides. The first side is the hypotenuse, and that's one that we are familiar with. It is across from that right angle. Our second side that we will label is the opposite. Now the opposite is across from theta. So all the way across, straight through the triangle, here's our opposite side. And the final side is the adjacent side. So the adjacent is the side that is next to theta. And those are the three sides that we need to be able to label: opposite, adjacent, and hypotenuse. So let's practice. Label the sides of the triangle as adjacent, hypotenuse, and opposite. I always start with my hypotenuse first because it's the most familiar. It's directly across from my right angle, hypotenuse. Then I always go to the opposite, which is across from theta. So that would be over on the right. And that leaves my adjacent, which would be on the left. And that is adjacent because it is next to theta. That is the side right next to the angle. We'll do another one together. Label the sides. I always start with the hypotenuse. It is across from the right angle. Here's the hypotenuse. And then I always go to the opposite, which is across from my theta. So in this case, opposite is on the top. And then finally the adjacent, which is the side left and remaining, but also adjacent is the side next to my angle, theta. Okay, you guys try. Hit pause, try it, and label all three sides. Okay, so the hypotenuse is across from the right angle, so it's on the bottom left there. Opposite's going to be on the top here, because it's across from theta. And then the side on the right is the adjacent, because it's right next to my angle of reference. Now that we can label our sides opposite, adjacent, and hypotenuse, we can start talking about our trig ratios. So a trigonometric ratio is a ratio of the lengths of two sides in a right triangle. And we have three of them. Sine is the ratio of the opposite leg and the hypotenuse. Cosine is the adjacent leg and the hypotenuse. And then tangent is the ratio of the legs. We have a mnemonic device to help us, SOHCAHTOA. So if I look at my right triangle with all of the sides labeled, SOHCAHTOA, sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tangent is opposite over adjacent. So SOHCAHTOA is using the first letters of each of those to make this mnemonic device. Let's try this out. Here's an example. Find each of the trigonometric ratios. The first thing we need to do is identify theta. So in this problem, it wants us to find sine of k, or cosine k, and tangent k. That means k is the theta. That's the angle we are looking at in reference to this triangle. Next thing, before you can find these, is you have to label your sides: hypotenuse, opposite, and adjacent. So I'll go ahead and do that. There's all of our sides labeled out. And now we are ready to start finding our trig ratios. Sine of k, that's the So sine is opposite over hypotenuse. Well, the opposite is 32. And the hypotenuse is 40, so 32 over 40. But we will always simplify these ratios. So 32 and 40 are both divisible by 8, so when I simplify this and reduce it, it becomes 4 over 5. And now we are ready to go to cosine. Toa. Cosine is adjacent over hypotenuse. So my adjacent side is 24, and that's over the hypotenuse, which is 40. 24 over 40. And again, we can reduce this ratio. Each of these values are divisible by 8, so when I reduce it, I get 3 over 5. And then tangent, that's TOA. So opposite over adjacent. Well, opposite is 32 and adjacent is 24. So that creates our ratio 32 over 24. And we know we can reduce this by 8. 32 divided by 8 is 4, and 24 divided by 8 is 3. So my tangent ratio would be 4 over 3. Okay, you guys try one out. Don't forget, we need to start off by labeling our angle, which is y, there's theta, and label the sides. So I've started that off for you. I want you guys to hit pause and find the trig ratios now. Okay, so sine, SOHCAHTOA. Opposite over hypotenuse, 36 over 39. Each of these values are divisible by 3, so we're going to reduce that ratio, 12 over 13. And we move on to cosine of y. Adjacent over hypotenuse. Adjacent is 15 and the hypotenuse is 39. And each of these are also divisible by 3. 15 divided by 3 is 5. 39 divided by 3 is 13. And our last and final trig ratio is tangent, TOA, opposite over adjacent. So 36 over 15. And we will also reduce this ratio, each of these being divisible by 3. So it becomes 12 over 5. All right, here's another problem, but the first thing I notice here is I am missing the side SR. Before I even start doing any trigonometry with this and finding ratios, I want to have all 3 sides. This is a right triangle, which means we can use our Pythagorean theorem. A squared plus b squared equals c squared. I'm going to plug 16 and 30 in for a and b because SR, the unknown side, is my hypotenuse. 16 squared plus 30 squared equals c squared. And now I'm going to go through, square my 16 and 30, add them together. 1,156 equals c squared. We want to solve for c. That means we are going to take the square root of each side. So the square root of 1,156 is 34, and that equals c. So I'm going to take 34 and put it up here on my hypotenuse of my triangle. Now I have all 3 sides labeled and identified with a side length. I am ready to start finding trig ratios. Start the same way. Identify theta, in this case is angle R, and then label your sides opposite, adjacent, and hypotenuse. Once you have those labeled, start working through your SOHCAHTOA. Sine, opposite over hypotenuse. 16 over 34. Each of those are divisible by 2. 8 over 17. Cosine is adjacent over hypotenuse. Adjacent is 30 and the hypotenuse is 34. Reduce your ratio, 15 over 17. And finally, tangent. Tangent is opposite over adjacent. 16 over 30. And this is also reduced by 2, 8 over 15. Some things to remember. Most importantly, you need to be able to label your sides, opposite, adjacent, and hypotenuse. If you cannot label those sides, then you're going to have a very difficult time finding the right trig ratios. And then after that, we need to understand SOHCAHTOA as a mnemonic device that helps us to remember sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. And that is all for our lesson.